Okay, so let's finish the problem. So we have this very simple equation. So we need to subtract. Let me do that here. So that will be 3 times then WA minus 3 times T minus WB plus 3 times T. That will be equal to, and then 3 times 3, that will be negative 9 MA AB, and that one plus, sorry, minus MB then AB. Okay, so let's replace the values, and then 3 times WA is, A was 50 kg, I believe. Let me check it. Yes, A is 50 kg and B is 15. Then 50 times 9.81 times 3 times T, this will cancel out. Okay, and then WB is 15 times 9.81. That will be equal to negative 9 times 50 times AB minus 15 times AB. Okay, so with these simple equations we can find what is AB here. That will be, 150 times 9.81 minus 15 times 9.81. So that will be 1324, and that one divided by the right hand side, which is 100, 450, 465. Okay, and then negative sign here. And then that means that AB is divided by 465, 2.84 negative meter per second squared. Okay, and then A is 3 times negative 3 times AB, and then that will be 2.84 times 3 is 8.52 meters per second squared. Okay, now let's see the problem statement. What does it ask for? And it asks for the velocity of B in 2 seconds. So that means that AB will be equal to dV by dt, and then if we separate and then integrate, then you will have then dvb. It is released from rest and therefore zero velocity. It gets something at the end after 2 seconds. Let me check it. 2 seconds, yes. So AB is constant, so we can bring it here. So it will be that AB into T will be equal to, from 0 to 2, then VB. From here it follows that VB is, AB is the negative 2.84, 2.84 times 2, 5.68 meters per second. Okay, one is negative, so AB is less than 0, and then AA is greater than 0. So it means that when B moves down, A moves up. Okay, and then vice versa. This is the result of the problem. Okay, now let's summarize what we did. So we started with a free body diagram, and then we mainly noticed that we have the body B that is supported by 3 cords instead of 1 cord, because body B is attached to D, and then D is supported by 3 cords. So that means that the tension force acting on the D will be different. That was our first notice. And then second thing is that we have to care about the number of unknowns and number of equations. That is the main problem when you try to solve the dynamics problems. because you need to find the number of equations that match to the number of unknowns. Okay. If they match, in our case we did not match, and we looked for additional equation, and that additional equation came from the kinematic relationship from our first lecture notes. And then that kinematic relationship says that the fixed datum, we have SD and then we have SA. 3 SD and then 1 SA will be total length of the chord. And then I ignored some segments that have a fixed length, because if I take the d by dt, then the constant parts will be 0 as the length of the chord. And then one more, then we have the acceleration terms, and acceleration of d is the same as b because they are attached with the same inextensible chord. And then we got the result with the 3 unknowns and then 3 equations. Thanks for watching, and then we will move to centripetal and then tangential acceleration.